wavelengths, and the images from NASA's WISE mission, the Wide Field Infrared Explorer, contained 2 billion sources. And which of those sources are the planet-forming disks? That's where we go to members of the public and ask for their help figuring out which of those needles in the haystack is a real planet-forming disk. No experience necessary. There's a short online tutorial. In about 5 minutes, you're looking at data, you're helping NASA, and you're potentially making discoveries.
NASA has many satellites orbiting the Earth that look at clouds from above, but we need your help to make matching observations from below. By getting the perspective from both sides, we can have a more complete picture of what's happening with clouds in the atmosphere. Satellites see clouds differently than human observers, and NASA scientists could never be in all the places they would like to be to collect data from the ground, which is why we need your help making observations.
So we've been traveling around the world using drones and this technique to map corals in 3D. And the biggest challenge we have with all of this data is how to classify it. How do we get the basic number of how many corals there are, how they're doing as a function of changing ocean temperatures? And that's where NemoNet comes in. So we built a video game that ties into our supercomputer, and you can download it and play it on your iPhone or iPad device. And what you're doing in that game is looking at our data sets that we are getting from around the world with these drones and helping learn about corals at the same time as coloring them and feeding data into our supercomputer.
On Planet Hunters TESS, we use data obtained by NASA's Transiting Exoplanet Survey Satellite, or TESS. So TESS is a space-based satellite that monitors the brightness of thousands of stars, and we need your help to find the planets within these data. In particular, we want to find the planets that the machine and computer algorithms tend to miss.
So auroras affect our technologies on Earth and in the sky in satellites, and they move really quickly, and it's important to get an understanding of what they're doing, and citizen scientists can really help with that.
What kind of discoveries have citizen scientists made with this project?
So one big one is something called Steve, which is actually an aurora that can be seen further away from the poles than the usual aurora. It's very unusual. It kind of looks like an airplane condensation trail, but with a photograph you can pick up these amazing colors as well. By studying it further with satellite data and other data from the ground, we've discovered it's really like a flow-driven aurora. It's an east to west flow that is lighting up the sky and doing some amazing kind of new, unusual auroral activity that's still being studied now.
We astronomers thought that disks stopped forming planets after about 5 million years, but then the citizen scientists at Disk Detective started finding objects that were able to form planets about 9 or 10 times the age of that, so into the 40 and 50 million year old age range. And the astronomy community is still trying to figure out what that means, so it's pretty exciting.
The second is, once you have all that data, it really doesn't mean anything unless you have humans come in and help annotate what it is we're looking at. To put it bluntly, they're changing the world. I mean, we have mapped, as of 2020, around 6% of the ocean floor.
Project in 2006, I think we had like 5 teams participating. Now we've got over 3,000 teams from 80 countries around the world that participate. Citizen scientists are able to look at these images and see deeper into the images than the automated detection utilities. Those are important observations because they're finding things that are missed in the original data.
Hello, my name is McDonald Chirara, and I've been part of the Globe Observer program, which is part of NASA's Citizen Science project. I've been involved in this project for the past 6 months. I decided to participate in this project so that I get the opportunity to do something cool and interesting in my free time.
please join us, because it's a very exciting thing to be involved with, to be able to report and share what I see. I'm not a scientist, I don't have a great camera, I'm not a professional, but I can be involved in something that's really important. And right now—
Hey everybody, greetings from the Arctic. Team Hearts in the Ice, saying hi.
Hi.
We want everybody at the CitSciCon to be super citizen science heroes.
It's so much fun. Join in.
All right, that was our video. We're going to get into our public sound check, and then we'll start promptly at 5:45. I am going to ask all the panelists we have here, I know a few others are still joining, but all of our panelists here to go ahead and get on camera so we can do our sound check and our audio check with you. So it looks like Chuck and Carl are both here. Hello, we're so excited to hear from you this evening. And we have Stella here as well. Awesome. Thanks for being here, Stella. Hi. All right, let's do a quick sound check. Maybe Carl can go first. Carl, tell us something you're excited about with citizen science, astronomy for your sound check.
Favorite part about citizen science is that anyone can do it from their backyard. I mean, it's amazing to think, especially in astronomy, that you can observe something 1 billion light years away from your backyard.
That is awesome. I love that. And then Chuck, what about you? What's something you're excited about with citizen science and astronomy?
Hello. Yeah, hello from Radio Jove. We're here to get people excited about radio astronomy. Maybe learn something about the sun or Jupiter. So I'm happy to share today.
Awesome. Thanks for being here, Chuck. And then Stella, what's something you're excited about with citizen science and astronomy?
Hi, and thank you for having me. What I'm excited is the fact that citizen scientists, with their means, can actually contribute meaningfully to science. They can contribute in very unique ways, and they can make an impact. So I'm here to tell you how, and thank you for the opportunity.
Oh my gosh, thank you. We're so grateful that you're here. I'm keeping my eyes peeled for our moderator, Vivian, so she can join. We may also have Mark Kushner moderate from NASA. And we're just going to keep our eyes peeled for any additional panelists, and we'll get started in about 5 minutes. Just as a quick FYI to our panel, we have been getting more questions in the Q&A box than we know what to do with. So we do have time set aside at the end for question and answer with our moderator and you all, but feel free to type answers to folks in the Q&A box throughout. Because we are going to have no shortage of questions by the time we're done here. One question Darlene wants to know, and everybody feel free to answer in the chat box. If you're watching on Facebook and YouTube, feel free to answer in the comments. If anybody here has a telescope. I don't have one, but I want one. So actually that might be one of my questions when we get to the Q&A section. What's everyone's telescope recommendation? Stella says she has a pair of binoculars. Very cool. And Vivian, if you want to come on camera really quickly, we're going to do a sound check with you. If you could tell us something you're excited about with citizen science and astronomy for your sound check, that would be awesome.
Hey, testing 1, 2. Can you see me? I cannot see you all for some reason.
Yeah, we can see you. We have our little preview slides up until we officially get started in about 4 minutes.
Got it. Sorry, I realized this was yeah, there you go. I'm ready. What was the question? Tell me one more time.
Something you're excited about with citizen science and astronomy.
Oh, I love the what they're doing with the excuse me. I love the art part of the citizen science. So last night we were on with Sips and Derek Pitts, and we talked about people who are doing very cool things with the Radio Jove, I think it is. That it was a one of the Nah, it was oh no, it was JunoCam. Sorry, that's what it was. Yeah, so Radio Jove is today. Hi, everyone. Now I can see you. That's better. All right. Sorry, I thought that started in 5 minutes, but I'm so glad you're all here.
We have a question here from someone who said that they're starting and they're looking for telescope suggestions. You know something, you can start with as little as a pair of binoculars. That's all I have. And or move forward or move upward or move any direction you want. Any kind of equipment you get will be useful and they will have an impact. You could even use a DSLR camera you already have. So you don't have to actually purchase a telescope, etc. However, you want more information, the AAVSO has an instrumentation and equipment section. Please join the section and ask. You'll get more than enough suggestions to completely confuse you and or inspire you. Thank you for the question.
Awesome. Well, we're going to get started in about 2 minutes. So Vivian, we'll turn it over to you in about 2 minutes. As an FYI for all our presenters, as you can see, we have a slide deck queued up. So during your presentation, when you want us to go to the next slide, you just tell us next slide. And we'll be taking Vivian's cues about timing. And of course, we're very excited for the Q&A at the end, which she will moderate for us. So that being said, for those who have tuned in early, don't be shy about getting your questions or in the Q&A box. And the chat is open for a lively discussion. If you want everyone to see your thoughts, make sure you select all panelists and attendees when you chime in the chat. We have 1 minute left. Any other questions from our panel? Any technical questions? Or things you want to clarify?
I just wanted to confirm, Stella, you are showing your own slides. That's right? Perfect.
Me too.
I'm going to just share.
And Chuck is showing his own slides as well. That's right. Okay. You'll see your slide queued up and then I'll stop sharing screen and then you can all share.
Great. Thank you.
And Carl, I just wanted to get a check on how to pronounce your name so I do it right.
Hergenrother.
Hergenrother. Good. I didn't know what kind of G that was.
Yeah, it's a hard G.
Great.
A raw rather than a row.
Oh, no, don't confuse me. Hergenrother, I'm in.
Yep.
Thank you. Nice to see you. Nice to see all of you. Hi, Stella. Hi, Chuck. And Mark is here. Hi.
Hi. Thank you so much for being here, Chuck and Stella and Carl and Vivian. This is a dream come true for me to get you guys all here chatting with our citizen scientists.
I think I'm going to skip my talk and just chat.
Right?
This is fun.
We're right at go time. So I think we'll hand it over to Vivian. Thank you so much, everybody.
Oh, wonderful. It is so lovely to see so many people on here. Welcome, everyone. I'm so excited. I think there are thousands of us out here joining on Zoom and Facebook and YouTube. And we're here this afternoon for me, this evening for some of you, and bright and early for some of you as well, to learn about NASA citizen science and find ways we can collaborate with scientists to answer questions that they can't answer alone. So that's what citizen science is all about. I'm Vivian White, and I work at the Astronomical Society of the Pacific, and I help to run the NASA Night Sky Network of amateur astronomers all across the US. And today I'm moderating this event that's brought to you by the Citizen Science Association and SciStarter.org, your source for real science that we can all do together. Let's see. There's a few reminders up there, and I just want to let you know that CitSciCon is a 2-day celebration of citizen science, especially NASA citizen science, featuring scientists who are describing their research and showing you how to get involved, as well as all of you volunteers sharing outcomes and experiences. So this session is telescope time, and today we're going to be learning about projects that require the use of telescopes and that guide volunteers to help scientists study planets and stars and asteroids and more. So discover these awesome and featured projects on the SciStarter CitSciCon page, and it's just scistarter.org/NASA. And when you visit this page, if you haven't already, go ahead and try and make a citizen SciStarter account. It's really easy. And that will help you be directed to all the citizen science projects that you'd like to see. And many of these projects work closely with SciStarter and help SciStarter members keep track of participation and earn certificates and badges. It's really fun. let's see, you've got the housekeeping notes up. So let's see, before we get started, if you're joining us on Zoom, go ahead and ask questions in the Q&A. We'd love to hear from you. And Stella's got the chat under control. I'm so glad to see. But feel free to say hi in the chat as well. And of course, if you're on Facebook and YouTube, you can post comments. We have moderators on those two platforms who are going to send your questions to us, and they'll be engaging with you to make sure your voices are heard out there too. Glad to have you wherever you're joining us. We have so many people tuning in from all over. This is really cool. That also means that we're going to have folks who have never even heard of citizen science. Welcome if it's your first time. And others of you out there who might have even been published in journals as a result of your involvement in citizen science. So we hope everyone has fun and finds something suitable for them, no matter what your experience is. So let's see who's going to be joining us today. All right, so I think there's a poll that just came up for you. You can read it. So if you identify as a citizen scientist, a teacher, a facilitator, a scientist, etc., those will be up for just a few more seconds. Go ahead and click what you are and hit submit, and we'll see who's out there listening. Excellent. So I love that you all, many of you, 80% or more identify as citizen scientists. Wonderful. There's lots of other formal and informal educators, students, and parents. Thank you. If you want to put in the chat what your other is, I mean, we all wear many hats, right? What are your other hats that you're wearing out there? All right. Excellent. Welcome to one and all of you. And I have one more question for you. Have you participated in citizen science before? This one, you're just going to choose one instead of multiple. Go ahead. We'll just be up for a few more seconds. I only got into citizen science maybe 5 years ago. Oh, great. There's a lot of you who have never participated in citizen science before. Welcome to you. I'm really glad you're here. I think you'll learn a lot. There's a lot you can do with and without telescopes. And today we're going to look at some of the things you can do with telescopes. So I'm really, really glad you're joining us. And for all of you who have been doing this for any amount of time, we're really glad to have you too. Thank you. Okay, I'm going to close the poll. All right, let's dive into the projects. That's why we're here. First up, we have Chuck Higgins. He's going to talk today about Radio Jove, and I'm going to let you introduce yourself. Chuck, welcome.
Thank you. I'll share screen. And great to be here, everybody. My name is Chuck Higgins. I'm at Middle Tennessee State University, but I do the Radio Jove project. And what I'm going to do is stop sharing because I wanted to show you something very cool live. We have some live streaming data, radio telescope data from a citizen scientist in North Georgia. What you're seeing here is radio frequencies from 16 to 24 megahertz plotted on the y-axis versus time on the x-axis, and the intensity is shown by color, by the color bar. And the top panel is 2 minutes of data. The bottom panel is 20 minutes of data. What you're seeing scrolling off the bottom panel, and I was kind of hoping we'd get going, that is a solar burst that just happened. I didn't plan this. Boy, if I could, that would be, I would be amazing. So that is a big solar burst that just happened that we observed with amateur radio telescopes and at these frequencies. So that's pretty cool. And so I'll talk a little bit more about these kinds of plots here in just a moment. So let me stop sharing this and go back to my regular presentation. Let me find it.
Chuck, that is so cool.
Yeah, that was pretty lucky, I think. Let's see here.
How often does something like that happen?
Well, the sun, as you know, goes through solar cycles, 11 years or so. The sun is just now waking up for the next solar cycle. So it's been pretty quiet for the last few years, but over the last couple of days, it's been kind of active. So it's hard to predict these kinds of things, but that's kind of interesting. So back to Radio Jove. So we are a citizen science project that encourages you to do a hands-on study of astronomy, but using radio telescopes. We want to facilitate, help you obtain, build, operate your own radio telescope. And the idea is to do that is you can listen to the sun or Jupiter or the background Milky Way galaxy or terrestrial radio interference. So we're using radio telescopes to study the cosmos. And in doing so, we are sort of seeing the invisible, right? We are using radio telescopes to obtain electromagnetic waves, radio waves, to help us understand, in this case, the sun or Jupiter. So let's see if I can play this. This is what a solar burst sounds like if you audibilize these radio waves. Let's see if I can. So what you're hearing is radio waves at 20 megahertz, then shifted into the audio so we can actually hear it. And what you see here on screen is a spectrograph. So what I showed you before is radio frequencies as a function of time with the intensity shown in color. And the right plot, so this was from a couple of weeks ago, and the right plot is a single frequency shown as a function of the intensity shown as a function of time for that same solar burst. And so Radio Jove, we want to help you build your own radio telescope. So we provide, it does cost money. So this is not free. And so we understand there's a barrier of entry for the cost, but the idea is that we're going to help you facilitate operating, building your own radio telescope. So the basic system is a small receiver that you can build yourself. It pairs with an antenna, and this antenna and receiver operate at 20 megahertz. And you see it's quite large, so you do need a little bit of space to set it up. And then the software that comes with it. And what you're seeing here is actual Jupiter radio emissions. So let me see if I can play my Jupiter for you.
Following is Jovian S-burst activity.
So those pops, those sounds are coming from Jupiter, the magnetosphere of Jupiter. So in radio astronomy, like other forms of science, we're doing remote sensing. So we're collecting these radio waves that are generated in Jovian's magnetic field, recording them, and we can learn something about Jupiter's magnetosphere. So the idea here, you build it, you operate your own telescope, you collect your own data, and you can even do some of your own data analysis, and we provide a data archive so you can get involved in doing science. And you see the basic system here is a few $100s, and we do have more advanced systems. So we try to help a beginner get started and one that can move up to intermediate and maybe an advanced. Sorry about that. More advanced projects. And let me just tell you, there's one of our, we call them super users, but Dave Topinski down in High Springs, Florida, is an amateur radio astronomer, but he's self-taught. Here's a picture of him. There's his lab where he collects his radio data there. He has a day job. He runs a tile imaging business, but he actually is so interested in radio astronomy. He's now designing radio antennas, and he's collected data for long enough that he actually presented at the American Geophysical Union conference last fall and is working on a scientific paper. So he has really elevated himself to almost the highest level now. And so that's kind of exciting. And, you know, anyone can do that if you're so interested. And so if you want to learn more about radio astronomy or getting started in radio astronomy, please contact me. That's my email, Chuck Higgins. I'm at chiggins@mtsu.edu. Visit scistarter.org/NASA and look for Radio Jove. You can join our email list and get involved. That's live software that I was showing you. That's free. So that's a way that you can get involved in radio astronomy for free, because you can connect to somebody else's radio telescope and monitor those radio emissions. And we have Jupiter, solar, ionospheric research projects. We have many dozens of participants, but I say we have really 12 really active citizen science that are contributing data and contributing science. And this picture right here that you see is an ionospheric events from lightning. And one of our citizen scientists pointed that out, and it resulted in a published paper last year. So it's a lot of fun. It's a real mix of course, astronomy, engineering, computer science is a way to do a hands-on project. So we're excited to be here. I want to thank Darlene, Vivian, scistarter.org, and Mark at NASA, of course, for letting us join you today. It's been great. I've enjoyed a lot of the talks. So I'll be happy to answer some questions for you guys in the chat going through the rest of the hour here. Thank you.
Thank you so much, Dr. Higgins. That was amazing. Please do write him. If you want to stick your email in the chat, that would probably be a good spot so people can just copy and paste. And feel free to ask questions there, and we'll have some Q&A time at the end. I love that you can do that either with the telescope, with the radio dish, or by using data that's already out there for free. So it's really nice that there are two ways to do that. Thank you. All right, next up, we've got target NEOs. I love, this is an incredible project as well. And Carl Hergenrother, I got it. Yeah, nice to see you again. Carl gave us a really wonderful talk back in November for the Night Sky Network, and I think it's one of the most viewed talks we've ever had. So it's really nice to have you here, and I'd like to hear all about your target NEOs. Take it away.
Sure. So I'm sure a lot of you have heard of the OSIRIS-REx program, which is a NASA spacecraft mission that just recently, I think just in the last 2 weeks, actually left its asteroid after about 3 years there studying near-Earth asteroid Bennu. And I was a part of this mission at the University of Arizona, though I've since left the University of Arizona just in the last few months. And Dolores Hill, who's also my co-coordinator, also at the University of Arizona, we were both involved with this OSIRIS-REx mission. And one of the things we were trying to decide was, okay, how can we get citizen scientists to help not only OSIRIS-REx, but future missions? Now, one of the things you may not think about when a mission like OSIRIS-REx comes up, and this is $1 billion mission, where do you go? Now, the scientists, of course, have an idea. They want to go to a carbonaceous object. This is an object that's mostly carbon rich, hasn't changed much over the history of the solar system. Well, okay, we know there's almost a million asteroids out there, but how do you end up choosing that one special asteroid that you go to, whether that's Bennu for OSIRIS-REx, or say Ryugu, which is the target of the Japanese Hayabusa 2 mission, which just recently sent samples back. And what you find is a lot of asteroids you can't really travel to because they're not in the right orbit. They're either too far from the sun, or they get too close to the sun, or their orbits are inclined, so you actually come out of the plane of the solar system. It would just take too large of a rocket, too much time, too much money, too much energy to get to. So if you're limiting yourself to only those asteroids that are not just near Earth, but have very Earth-like orbits, you quickly find that the number of potential targets drops from, say, 1 million to now we're talking maybe a few hundred, maybe a few dozen. And the problem we ran into when we were trying to find a target for OSIRIS-REx was, okay, we identified 26 asteroids we could go to just based on their orbits, the energy, the time. But we only had physical characteristics for maybe 5 of them. And that was it. So we decided, you know, can we come up with a program? You can go to the second slide. We're just using, you know, regular backyard instrumentation. I mean, you do require a camera, whether that's a CCD or a CMOS, it could even be a DSLR, but it has to be, you know, some photometric accuracy with the camera. But using telescopes, and we've had observers use telescopes as small as 6 inches in diameter, so we're not talking, you know, a meter, 2 meter telescope, we're talking relatively small telescopes. How can you turn something that's really in your telescope just looks like a dot into an entire world? How can you learn so much about this asteroid that a future mission that is considering where to go can actually use this knowledge and either decide this is a good target or this isn't a good target? Third slide. So we came up actually with 2 programs, so they're very similar to each other. One was Target Asteroids, and that was specifically run out of the OSIRIS-REx Communications and Public Engagement Program. And then we had Target NEOs, which is pretty much the same exact program, but it's run with the Astronomical League. And in fact, this has become one of the Astronomical League's observing programs. And for those who are may not be aware, the Astronomical League is kind of an overarching organization that includes a lot of the astronomy groups around the world, especially the United States. And they have these observing programs. Everything from simple observing programs like, you know, observe all the Messier objects to observe all the objects in the Herschel list or observe a whole bunch of red carbon stars. And, you know, you'll take observations, whether it's visual or CCD, you document your observations and you'll get a pin or a certificate. And so that's what we do with the Target NEOs program. We have a list of asteroids that we are interested in studying. Not all are near-Earth objects, even though right now we are Target NEOs. They're not all near-Earth objects. But we have a bunch of different objects, from objects that would make good spacecraft targets in the future to objects that possibly were the parent bodies of these good spacecraft targets. And so we've partnered with the Astronomical League. We've partnered with Patrick Miller's group, Isaac, who gave a talk in one of the earlier sessions, as well as Herbert Robb, who writes the Astrometrica program, which is an excellent program for taking asteroidal data and coming up with astrometry and photometry from your data. So next slide. So exactly what do we do? As I mentioned before, we run a series of campaigns where I identify an asteroid of interest, and it could be a main belt asteroid, it could be a near-Earth object. Sometimes it's even a comet, or an extinct comet, or a low-activity comet. And the main belt objects that we run campaigns on are usually objects that probably were parent bodies for objects like Bennu or Ryugu that, you know, spacecraft are going to. Because all these objects in near-Earth space originally started their existence out in the main belt. And then there were collisions, objects broke up, and these smaller pieces eventually hit a resonance. And over time, you've got gravity and it pushes it into the near-Earth space. So the thing is, join a campaign, observe. It doesn't have to be your telescope. There are a lot of organizations out there, though usually they're, you know, it's for profit, but not always, where you can use telescopes located all around the world. And that's, for example, how I do a lot of my observing. It's easier sometimes to just get on the internet and use a telescope in New Mexico or use a telescope in Australia versus lugging out all my equipment and setting it up in the backyard. We use programs like Astrometrica to then reduce that data. And as a contributor, you can either do these reductions yourself, and we'll be happy to teach you how to do it, get you access to the programs, but you can also send us the data and we'll do the reductions and do the photometry on there. Of course, we analyze the data, and ultimately it results in publications. And I'm happy to see that one of our co-authors on this 2002 CE26 paper, Alessandro, is actually, I think, here on the participants list. Go on to the next slide. So exactly what kind of science can you get by just observing an object even a few times a night from your backyard? Well, as the objects are moving around the solar system, we're observing them at different angles, different specifically what we call phase angles, which is actually the sun, asteroid, Earth, or observer angle. And as you observe an object at different angles, it gets brighter or fainter, just like the moon. If you observe the moon at full moon, it's really bright. If you observe it at crescent, it's a lot fainter. And you can plot up the change in brightness with phase angle. And there is a correlation between the slope of that line, and this is the leftmost plot here, and the actual albedo. The steeper the slope, the darker the object. So without requiring something like Spitzer or a thermal infrared camera, you can indirectly measure the albedo of an asteroid by simply observing it a few times a night over many nights as the object is observed at different phase angles. And of course, if you decide to observe an object, say for many hours or even the entire night, you can watch its brightness change as it rotates. And the bottom plot is actually a light curve of a near-Earth asteroid that's rotating on the order of, 2.7 hours. And you can see its little undulations in its light curve. And if you have filters, you can observe in different filters. And then once you account for the rotation and the phase angle changes, you can kind of get a low resolution spectrum of the object. And that can tell you exactly what kind of asteroid is it. Is it a carbonaceous object? Is it a stony object? So next slide. We've had a lot of great contributors. I'd like to spotlight two of them, Patrick Wiggins and John Briel, who in some cases were observing every night for hours a night. Patrick is also really good at discovering supernova. He's got a nice setup in his backyard. And both John and Patrick have been submitted so much data and been so impressive as citizen science contributors, they now actually have asteroids named after them. And we'll end on the final slide here, which is kind of the call to action to go to the SciStarter website, as well as the Astronomical League's website, where you'll get all the different information and contact information, how to register for Target NEO, how to obtain access to small, or if you have one, a large telescope, we're not picky, and the various campaigns that are active and how to get started. So thank you.
Thank you so much. That's great. There are so many ways to get involved. And I know there are lots of people asking for links. If you go to scistarter.org/NASA, you should get to many of them. But Carl, if you want to put in the chat some places where they can find the data and then work with yours, that would be great too. Thank you so much. And it looks like next up we have one of my sheroes. We've got Stella Kafka from the American Association of Variable Star Observers, or AAVSO, as most of us know it. It is so lovely to see you and have you here. I cannot wait to hear about what you're up to lately. I'm just going to let you take it away from there.
Thank you. Thank you, Vivian. Thank you all for having me here and for giving me the opportunity to discuss how the AVSO builds communities of citizens, both professional and amateur astronomers, through science. I'm given 10 minutes, so this is going to go really fast. The dictionary defines community as a feeling of fellowship with others, a result of sharing common attitudes, interests, and goals. So here's our community. The AVSO was formed out of Harvard College Observatory in 1911 to coordinate variable star observations for then Observatory Director Edward Pickering. In principle, the AVSO was the first association that was founded in order to connect professional and amateur astronomers and help them collaborate on scientific projects. We are the original citizen science association in astronomy. And yes, I brag about that. Now, since 1911, we have evolved. We have become an international community of more than 7,000 individuals from 50 different countries. And as a consequence, we have a very diverse community. This translates to serving people with different needs, different priorities, different professional preparation, different habits and cultural backgrounds who are united under the international umbrella of astronomy. Remember, astronomy has no borders. We have individuals who are interested in using variable star data for their research projects. We work with educators who introduce astronomy to their students. We collaborate with a very dedicated group of volunteers. We communicate with astronomy enthusiasts who are just interested in learning more about new science discoveries and support citizen science. And of course, we work with our observers. those who acquire data through their telescopes, CCDs, DSLR cameras, and share their information and the data with the wider community through the AVSO International Database. The science we do is variable stars, stars whose brightness is changing with time, within timescales we can measure from Earth. Those changes are results of stellar properties or stellar interactions, nothing to do with the Earth's atmosphere or observing conditions. These are just some examples of the variables we're working on. The sky is full of all types of stars to keep us awake at all times of the night or day. And I say day because the sun is a variable star and it's one of my favorites. So from here, pick your favorites. The sky is not the limit. We have eclipsing binaries, we have exoplanets, spotted and flaring stars, pulsating variables, we have supernovae, we have novae, we have gamma ray bursts, protostars, irregular variables, the sun, Betelgeuse. Pick your poison, pick your favorite new friend, and observe and explore it. So here's some of the specific examples of projects our communities evolve with. So let's start with some NASA projects. We're continuously engaged in simultaneous ground-based support for NASA missions. For example, the Hubble Space Telescope, Chandra, Swift, Fermi. For example, one of the most common support we provide is when a PI, a professional astronomer, has time on HST, the Hubble Space Telescope, to observe variable stars whose brightness can change dramatically and unexpectedly by 5 to 10 magnitudes within days. So imagine like more than 1,000 times. For example, novae and dwarf novae. AVSO observers, per the request of the PI, continuously monitor those targets up to the day of the designated observations, and we give permission to the Hubble Space Telescope to observe. So in principle, we save HST from unfortunate accidents due to a star's erratic and crazy behavior, and we enable this kind of science to happen. We also do follow-up of interesting targets that result from ground-based and space-based surveys. So for example, we contribute to test ground-based follow-up, exploring whether transit candidates, exoplanet transit candidates, are real or they're eclipsing binaries mimicking exoplanets due to an unfortunate close foreground or background companion. We also provide multi-filter photometry and spectroscopy of targets of interest to the community in cadences or in frequencies outside the capability of those missions and surveys. We also encourage our observers to participate in what we call high-risk, high-reward projects. So for example, Slooh is an international collaboration. Right now we have more than 12,000 individuals as part of that, both professional and non-professional astronomers, trying to monitor, understand, and catch the next brightest supernova. Which one do you think is going to be? Is it Betelgeuse? Is it Antares? One of those crazy stars that are there that are nearby? We are very engaged with this group. We are monitoring nonstop the targets, but also we are participating in drills with their alert system so that when something like that happens, we are on target as quickly as possible. Gamma is similar, but with gravitational waves. So we're going to be looking at gravitational wave follow-ups once one of those goes off. We have also a very active set of alerts and campaigns. These are individual targets that professional astronomers are very interested in monitoring, and they come to the AVSO and they ask for our observers' help. And of course, we encourage our observers to have their own projects. We want you to actually pursue your own observing program or adopt a star or two to observe every now and then. Every data point matters. So as a result, our citizen scientists' data are routinely used in referate publications, some of which include those individuals as co-authors. Actually, most of them include those individuals as co-authors. And for us, it's very encouraging to track those publications through NASA's ADS system. This is just an example of the number of referee and non-referee papers over the just last 10 years. So there's way more. We have 110 years of history, right? And these are used, AVSO observers' data, and resources for this particular science. So we're building up 2021. I guess the bottom line here is if you have a pair of binoculars, a DSLR camera, a telescope, a solar telescope, if you would like to explore the universe through your telescope or through your eyes, with your eyes, you can participate in variable star astronomy and contribute to science. Even if you take just a couple of data points every now and then, they can provide very significant information on the secret lives of stars. So if you can do this, you can definitely do this. These are visual observations through binoculars of a dwarf nova. And actually, I will dedicate the rest of my slides, there are 4 more slides, to show you how the AVSO is here, how we are here to guide you and help you from the beginning and along the way, provide you the tools that you need, the assistance that you need to participate, and actually help you join us in this super duper global party where we're celebrating science and scientific outcomes that come from our community. Everything I will talk about is on our web pages and it's free to access, download, and use. So let's start. What's our role? We provide training. We understand that astronomy may be different than your professional preparation, and perhaps you're not familiar with astronomical data acquisition techniques, way to best use your instruments or telescopes, commonly use astronomical software. Oh my gosh, this crazy lexicon that is called astronomy. Sometimes you hear people talking and it's like they're talking complete different language. We provide relevant training from zero to take and submit data, constantly helping our observers, helping people like you to improve your skills and provide the best data you can. This training comes in forms of manuals, online courses, mentoring, in-person, remote workshops, and how-to hours. We also continuously work to help our community better understand the science behind the data. We want you to be a scientist. So for example, we have online webinars free for all, just to hear from professional astronomers how data is being used, what data is being requested and are necessary for different science projects, and actually how you can contribute. We have a very active help desk at headquarters. You're not alone. We're available to answer technical questions, provide feedback on data sets, connect you with mentors, help any way we can. We also build scientific collaborations. We build alliances with key projects so that you can get involved with really cool projects. You will hear about Exoplanet Watch in a minute, so I'm not going to tell you more, but that's just one example of how we are connecting you with scientists and with targets of interest. We also provide you software for data analysis and reduction, software for CCD and DSLR data reduction. If you want to use it, you don't have to use any of that, but it's an opportunity for you to use software that is very friendly. It's not written by professional astronomers because that's becoming complicated. It doesn't require a lot of background knowledge in astrophysics in order to use it. We also have a journal. This is an opportunity for you to publish your science if you want. It is a referee journal, and actually since 2015, the journal has been double-blind refereed, meaning that you don't know who the reviewer of your manuscript is, but the reviewer doesn't know who you are. This removes any unconscious bias from the reviewer's side, and they ensure that manuscripts that are being published in this particular journal are just based on their intellectual merit alone and not the affiliation of the author. This is also an effort to provide equal opportunities to individuals worldwide to publish your own work in a refereed journal. We provide data quality control. We receive data from people with different equipment, visual DSLR, PEP, CCD, CMOS, that they have their own peculiarities, and it's not uncommon to receive discrepant data, either observations of the wrong star, software glitches, not reporting the right filter, saturation, and all kinds of stuff. And actually, it's proven that the experience of an observer has nothing to do with whether their data is discrepant or not. Glitches happen, right? So we check as much of the data as possible, and we're providing feedback to observers, helping you understand your data and helping you improve your skills along the way. This is quite a large task considering the volume of data that we're receiving, but we're doing as much as we can. We have even a group of volunteers who are helping us. Just to give you an idea, last year, our photometric database received 2 million new data points on all types of variable stars. So, and yes, we check them all. We also curating AVSO databases. Small telescope, binocular, DSLR image data are different and more inhomogeneous than professional astronomical data. And we are committed to make sure that those databases, that data is being curated and safeguarded for the rest of the AVSO's life. So we've had 110 years of history. We're hoping for a couple of millennia So this is something that we do and we're offering for our community. And this is actually a way for the professional astronomical community to download data and make them available. But
go ahead.
Yes.
Oh, I was just gonna say it's a huge service. We have one more presenter, so I just was gonna give you a time.
Give me 2 minutes.
Oh,
so
how about
for
one?
me, most importantly, we're building inclusive and diverse citizen science communities. We strongly believe that a diverse and inclusive citizen science workforce drawing from the widest range of backgrounds, perspectives, and experiences leads to maximizing innovation, increases productivity, and benefits science measurably. So for us, you're welcome to join us. Let's explore the universe together. This is our webpage, and I'm going to put it on the chat. Any email, you can contact us. And from there on, all you need is clear skies. Thank you for your attention.
Stella, that is fantastic. Oh, it was a great presentation. I'm glad you got to your last slide, and it was really, really lovely. You were doing such a huge service for the astronomy community and allowing so many people to participate. I really appreciate that. Thank you. You're awesome. And we have another awesome program, Exoplanet Watch. We've got Rob Zellem here, and I am thrilled to welcome you. I'd love to hear all about yours. Exoplanet Watch is another one of my favorites. I say that every time, but it's actually true. You are all for some of my favorite citizen science projects. So take it away, Rob.
No worries. Actually, Zoom is making me restart, so I will do that really quickly.
Oh, yeah.
If you don't mind.
Take your time. No. We'll come back to you. We actually have a special guest here today. A last minute joiner. Paul, are you there? Dr. Paul Cox is here from Slooh. I was just going to pull him in at the end and say hi. Hi, Paul Cox is here. This is another citizen science project. Slooh is one of the telescopes that you can, there were a few questions in the Q&A session about telescopes that you can look through from your home, and Slooh is one of them. I just wanted to mention a few others. The AAVSO has some as well, and Harvard Micro Observatory. Those are two others, just so you have some options. But Slooh is amazing, and they are doing really great variable star photometry with AAVSO. Oh, okay. Rob, give us 1 second. I'm just going to introduce him, and then I'm going to get right back to you. Okay. And they have nova and supernova discovery projects. So you want to just say hi, Paul, and we can catch up with you again in the Q&A.
Yeah, hi everybody. But let's go over to Exoplanet Watch. I'm interested to hear about this one.
Me too. I'm really excited. We'll catch back up with you afterwards.
Thank you.
Thanks, Rob. Thanks, Paul. All right, Rob.
Sorry, everyone. Brand new laptop, so I have to get used to setting everything up properly. So hopefully you're seeing the full screen mode and not the presenter mode. Cool. All right. Yep. So thank you everyone for having me. Really appreciated this. This conference has been amazing, and I really want to thank everyone for having me. And I hope this becomes an annual thing because this is just really exciting and inspiring to see. My name is Dr. Rob Zellem. I'm an exoplanet astronomer at NASA's Jet Propulsion Laboratory, and today I'm talking about Exoplanet Watch. This is a citizen science project to observe transiting exoplanets. So what is a transiting exoplanet? Well, an exoplanet is any planet outside of our own solar system. And a transiting exoplanet is one that occasionally passes in front of its host star. And what happens is the planet passes in front of its star, it blocks out some of the star's light, it actually casts a shadow all the way back on the Earth, and it makes the star look a little bit dimmer. And the size of how much light is blocked out tells you how big that planet is relative to its host star. And this is really important because this tells us how big exoplanets are, but also we can use the transit method to directly study the atmosphere of these planets by observing how the planet's atmosphere blocks out light from its own host star. And this method's been really used very successfully. This has been used to discover 3,000, about 75% of all the currently known exoplanets to date. So this is really cool because there's actually a mission right now, NASA mission called TESS, that is flying, and this will be discovering and has already discovered tens, if not hundreds of exoplanets. And this survey will discover potentially an extra 10,000 exoplanets. So today we know of 4,000, TESS will potentially discover an additional 10,000. And why do we care about knowing about all these different exoplanets? Well, it's because we can use the transit method, like I mentioned earlier, to study the atmospheres of these planets in detail. And the transit method has been used by various NASA missions, for example. So the Hubble Space Telescope has looked at tens of planets to look at what their atmosphere is made up of. The James Webb Space Telescope, which will be hopefully launching in the next few months or so, an absolutely massive telescope that'll be using the transit method to look at tens or hundreds of planets. The Ariel mission, which is a European Space Agency mission, this is actually a dedicated mission that'll be looking at the atmospheres of hundreds to thousands of exoplanets. And we totally expect the transit method to be continuing to be used in the future. The next generation of NASA flagship missions that are currently under study right now will likely use the transit method to look for biosignatures or signs for life. So the transit method is something that we'll definitely be using now and also in the near future to look at atmospheres and to potentially answer one of those age-old questions: is there life out there in the universe? But in order to observe a transit, you have to know exactly when that transit will occur. You have to basically keep things fresh. So if I want to observe any random exoplanet with a large telescope, like Hubble, for example, and I think that that transit happens here at that red dashed line, let's pretend that there's some uncertainty in the transit. Let's say that the next time that it could happen, there's like a 15-minute uncertainty, and it could happen like 15 minutes earlier than I anticipated happening. Well, that's an extra 15 minutes I need to build into my observing campaign with the Hubble Space Telescope. And at the end of the day, that's really using these very, very precious resources in a less efficient way. And we really want to maximize the efficiency of these telescopes so they can do other cool science and not just be wasting their time, doing really cool cosmology, looking into black holes and gamma ray bursters and galaxies and stuff like that. So this idea really started to make us look towards the power of small telescopes. We have a really great collaboration with a micro observatory. They have robotic telescopes in Arizona and Massachusetts, and that's an array of 6-inch telescopes. And by looking at their data, we were absolutely blown away about the data quality from something roughly about the size of my hands right here. They're able to get very high precision measurements. And here's an example transit I'm showing here of a relatively dim target, P32b. This is a Jupiter-sized planet orbiting around a sun-like star. And this planet, you can see here, here's the star. The planet gets in the way of the star and causes the star to dim. And the size of that dimming or that dip in its brightness tells us the size of that planet. And we were amazed about this high quality data set. And we got to thinking, there's hundreds, if not thousands, of amateur astronomers across the world with 6-inch telescopes, 4-inch telescopes, even larger telescopes that are capable of doing really scientifically impactful science. And that got us to thinking about launching a new project called Exoplanet Watch. And Exoplanet Watch strictly is a campaign, a citizen science project, where amateur astronomers such as yourselves can help us by observing these transiting exoplanets. And you can whittle down those uncertainties in when the next transit will happen. And therefore, astronomers like myself can then write proposals and use large telescope time, Hubble, James Webb, large ground-based telescopes, and use them a lot more efficiently. So that way their time isn't wasted, and they can basically hopefully enable them to do even more really cool, impactful science. Other cool facets about this project is the data will be immediately public to everyone, regardless if you're an astronomer, a professional astronomer, or an amateur, or anyone. And also there's an opportunity for community feedback, for target requests. Our collaboration, our group has really benefited by a bunch of our beta test users. Hopefully some of you are watching here today who've really helped guide our project in a positive way and really enriched it. So we really are very appreciative to all of our citizen scientists and our volunteers. And this is totally funded by NASA's Universe of Learning. Another cool facet that I'll come back to in a minute is if you contribute data and that data is then used in a scientific publication, you will be listed as a co-author. If you're doing the work, you deserve the credit at the end of the day. So we have these two overlying goals by our project. We have an educational goal to hopefully engage all of you in citizen science and exoplanet citizen scientists and increase your confidence about your ability to do science. but also the scientific goal to ensure the sufficient use of large scopes, potentially also help us discover new exoplanets, and also monitor for stellar variability and a bunch of other cool science cases as well. So let's quickly take a quick overview in my last 3 minutes of the user experience. As a user, what you do is you plan your observations. There's many different ways you can do that. You then use your own telescope, your own digital camera to observe your own transiting exoplanet. You turn those images into a transit light curve, you reduce it, or you analyze your own data. You're free to use any sort of data reduction code you want. If you want to use AIJ, AstroImageJ, you can use our own homegrown one called Exotic. Use whatever you want. The only thing that matters at the end of the day is that it's in the right data format for upload to the AAVSO. And we're very, very fortunate and very happy to have this awesome collaboration with the AVSO. And you can upload your data to their exoplanet database. And what we do is we scrape all that data and we make it available to the entire community. And then you can publish it. All of our data is immediately free and public and available to anyone to use. So you can go on, please go ahead and scoop me, take some data and publish some results. That would be awesome. And speaking of publishing, even though we still haven't officially launched yet, we actually already have publications coming out of this project. I was very fortunate to publish a paper last year. And in green, I've highlighted a bunch of amateur astronomers. You can see they're actually in the first half, and they beat out many other professional astronomers because they've contributed in such a giant way to this paper. And I'm very, very appreciative of all their effort and work. Also, I'd like to highlight these 4 other papers. These are actually written by high school students that have taken their own exoplanet watch data and data products and wrote their own studies. And hopefully, they have these awesome publications as a result from it. So one thing that you might not be seeing that sort of happens behind the scenes is what happens on the JPL side. We have these 2 servers, and what they do is they reach out, they grab all the data every single day from the AVSO's database. Then we process the data on ourselves internally, and then we publish all of that data immediately to our website. And one last thing I'll mention is we do have our own exoplanet data reduction code. You can actually use it to analyze your own observations and reduce it and put it in that data format that you need to contribute your data to our collaboration. I've listed the link there on the website, but I'll also list a link in the chat in a moment after my talk. And we are looking for people to help us test this out and make it much more user-friendly as well. So that's a very whirlwind sort of description of Exoplanet Watch. I'm really excited to talk to all of you. We'll be launching towards amateur astronomers and those who are studying astronomy degrees in colleges and universities in the next month or so. And then hopefully by the end of next year, we'll be expanding it to anyone and everyone who's interested in participating in the science by contributing and basically giving out telescope time on some of our robotic telescope partners to you for free. So stay tuned. If you don't have your own telescope, hopefully you'll be able to be involved in the next year and a half or so. So with that, thank you again for having me. I really appreciate it.
Thank you so much, Dr. Zellem. That was wonderful. That is a really excellent way to get involved if you don't have your own telescope. So there have been a lot of great questions in the chat. I just want to give Paul a quick moment before we get started with Q&A. If you do have questions, go ahead and stick them in the Q&A if you're joining us on Zoom, and we'll pull some of those up in just a minute. Paul, hey, welcome.
Hi, thank you. Hi.
Hi.
Well, thank you for this very late invite. A huge thank you to Darlene from SciStarter for connecting us to the event, and Vivian, to you and the NASA Night Sky Network team for inviting us at this kind of last minute for a very brief intro to Slooh.com. So it's not a presentation, haven't got anything for you, haven't even got a fancy background. I'm not even at my home at the moment, so apologies for video and audio quality, but I've just been listening to these presentations, and isn't citizen science the coolest thing ever? You know, because so many people buy telescopes, but they don't have a purpose to use it. You know, so many people have access to telescopes like Sloohs, but they run out of steam because, yeah, they've seen a globular cluster, they've seen a nebula, admittedly in full glory of live color, but you soon run out of a purpose. And that's what all of these projects give people to do. And it's something that we found over the years with Slooh. Slooh, I'll give you a very, very brief intro on this. I'm just going to kind of skip through what we do, but it's, I could fill 4 hours of this, and quite often do actually on our live events. But anyway, we often refer to Slooh as the best kept secret in amateur astronomy. It was launched on Christmas Day 2003, and it's a worldwide community of space enthusiasts and astronomy enthusiasts and citizen scientists sharing the sky with Slooh's live telescopes. Now, I'm not a professional scientist, I'm not a doctor. I'm a very proud amateur astronomer, just like actually my great hero, Sir Patrick Moore in the UK. And it's interesting when I'm at Slooh's observatories, when I meet some of the professional observers there, astronomers there, and I take them up to Slooh's observatories. I'll tell you a little bit about those in a sec, but they are absolutely astonished at the quality of the equipment which is now available to amateur astronomers around the world. But there's a huge complexity in using them, especially for some of the projects that we've been hearing about tonight. You start getting into CCD astronomy, and it can be pretty complex to set up, let alone battling with light pollution and the weather. I live in the UK, so I bought loads of wonderful telescopes 20 years ago and actually discovered, I could probably use them 2 nights a year. And that's actually when I discovered Slooh. But anyway, Slooh's observatories, we've got 2 observatories, one at the Institute of Astrophysics of the Canary Islands. If you ask a lot of people, where's the largest optical telescope in the world? A lot of people will say Hawaii, or they'll say the Atacama Desert or something like that. But actually it's in the Canary Islands. It's the Grand Tecan telescope. And that's where Slooh's telescopes are based. We've got 5 nighttime telescopes there and 1 solar telescope that operates during the day. The 5 nighttime telescopes are all tuned and designed to be a specialist in particular subjects, so in particular areas. So we've got our 1/2 meter telescope and our 17-inch telescope. Sorry, I'm mixing up the old metric and imperial there, but 20 inches and 17-inch telescopes. Large format CCDs, cameras. Those are the 2 telescopes that our members primarily use for the science. We've got other telescopes which are designed to be optimized for planetary observing and stuff like that. But we've also got a second observatory which gives us full sky coverage down at the Chile Catholic University Learning Observatory down there. We've got 3 telescopes there. This time last year, I installed a new Planewave CDK 17-inch telescope. And that's the nice thing about that is we have exactly the same telescope system with CCD and the same filters at the Canary Islands and in Chile, which becomes incredibly useful for our members who are performing photometry. But anyway, a little bit more about the citizen science that our members do. The longest running citizen science type work that our members have been doing is near-Earth asteroid tracking. And it all started back in 2008 with asteroid 2008 TC3. I haven't got any notes with me, so huge apologies if I make a huge mistake on some of this. But our members were among a handful of people who managed to image this particular asteroid before it impacted the atmosphere over the deserts of Sudan, which was an extraordinary feat back at that time. And that suddenly, spurred the enthusiasm for tracking near-Earth asteroids in our community. And over time, over the following years, a group of members formed. They formed a club called the A-Team, and they track near-Earth asteroids. They decided that they would develop a whole training program to help train other people. And other members can now get one-to-one mentorship through this fully structured training course. And then they're given consent to make submissions to the Minor Planet Center. And we do that because actually the group of members are so proud of the quality of their submissions that we actually limit submissions to the Minor Planet Center for that. But anyway,
well, I just want to give you one more minute because I want to get to some questions we've got in the chat.
Absolutely.
Thanks.
So I'll skip very quickly just through the other areas that members are doing science with at the moment. Comet monitoring, got a huge club. Track comets, worked with the Pro-Am Comet 67P campaign a few years ago. Looking forward to another one of those this year. Comet recoveries as well, because our telescopes can point down as low as 3 degrees above the horizon. Variable star, so Stella's going to be pleased to know that loads of Slooh members are members of the AAVSO and contribute photometric measurements to their databases as well. We've also got other groups who have discovery programs for novae, supernovae, and also a lot of members doing a lot of the Astronomical League program. So that is Slooh in an absolute nutshell. I'm sorry it wasn't quite as short as I had tried to make it, Vivian.
No, that was great. I appreciate that. I just want to there's some really great questions. And
Yeah.
I want to thank you, Paul, for stopping by. I'm really glad you got to join us too.
Thank you.
There is such a great community, the amateur astronomy community, the citizen science community. There's a huge overlap, first of all, but Stella had said earlier about, the community is what makes this really much more fun, because if you have a telescope by yourself, that's one thing to be able to observe every night, but having this community built in where we can help each other and riff off of each other's experiments or observations, it's really lovely. So I am glad to be in community with you all. There are some really great questions. One that we got that it sounds like we get quite a bit, or the citizen science community gets quite a bit, is, okay, I'm new at this. Can I mess it up? Is this something I could take some data and submit it? And what if it's not great or not the way you need it? How do you all do that, Stella? Yeah, you let us know how you work that out. Thanks.
I alluded to that. Actually, you should mess it up, otherwise you're not going to learn. And please remind me to tell you stories about the first time that I took data. But at the AVSO, we're here to help you. We're checking every data point that comes, especially for new observers, and we're providing feedback, and we help you understand if your data is discrepant, the reason why the data was discrepant, and help you improve your skills, your observation skills. None of us here was born with a telescope under our arms. And no, our first toy was not a DSLR camera to go observe the night sky. So we all learned slowly, and we all learned together. That's what I love about communities. So we have mentors, each and every one of us, just reach out to us, really. And I know I'm volunteering everybody else, but I know that, again, that's why we're here. We are a community of citizen scientists. So just do it. I know I'm stealing it from Nike, but that is my motto as well. Just get started. If you don't get started, you're not going to improve.
Excellent. Anyone else want to take that? I agree that somebody put in there, Tara from SciStar, the fail is just a first attempt in learning. It's so true. If you don't try, you'll never succeed. So excellent. Yeah. So these projects have a lot of safeguards, and we expect to fail because that's how we learn. So well done. Appreciate that growth mindset. There are some questions. There are quite a few questions about what is my first telescope that I should get, and that is Stella also had some advice about that earlier. Starting off, if you've never looked up in the night sky, it's great to start with a pair of binoculars, like she said. That's a really wonderful way to learn the night sky. I think there's a lot of head shaking going on. And starting with online telescopes can really help you get familiar with what you're looking at. So that's a great way as well. Is there any, Carl or Rob or Chuck, do you have? Yeah,
I always tell my students who are interested in buying a telescope, don't buy a telescope, find a friend with a telescope. Find a local amateur club, use theirs, learn from them, and understand the telescopes better before you buy, and then go buy your telescope. I do the same. I don't own a boat, but I don't want to own a boat, but I have a friend with a boat, so I'm going to go borrow my friend's boat, and then that way I don't have to buy one. So the same works for telescopes.
Really good point. And amateur astronomy clubs often have loaner programs, or someone there who can introduce you. You can look through their telescopes to get started, see what you like, see what is kind of the right size for carrying around, or where you want to put that. So yeah, there are lots of really good people out there in the community who like to share. All right. For you all who are presenting, there were some great suggestions to hook up with cloudy nights. That's probably for everyone as well. It's an online forum where you can get lots of questions answered about telescopes and also astrophotography and many other places. So that's just another resource for you out there. How about becoming co-authors? Is that something that just anyone can do? Sounds like many of you have had citizen scientists become co-authors. Thumbs up all the way around. Yeah, excellent. And go ahead.
Just one thing, all of us here consider citizen scientists as collaborators. Somebody's taking the data, someone else may be analyzing it, a third person may be coming up with results, and we're all writing the paper together. So yes, you deserve, if you put the work, you deserve to be a co-author. And everybody's nodding their head. So, yep.
Oh, Lisa talked about in the chat about the local libraries. Many of the libraries are now doing telescope loaner programs, so you might even be able to hop onto that. Great. And how about, there was another question about how to get involved with the training with AAVSO. I know you all offer amazing training. How would someone get involved with that?
Go on our webpage or send us an email. Depending on your learning style, we have different ways of training individuals. So we have a whole bunch of manuals of anything and everything you might do, from exoplanet observing that includes Astroimage J to DSLR, CCD, binoculars. I'm a professional astronomer. I've used big telescopes in my life. When I started my binoculars program, I asked for a mentor. And I read our manual as well. We have online courses, we have workshops. There's so much in there, and it's all on our webpage, up from a center where it says education. So come join us.
Yeah, training and community is free, which is fabulous. Thank you. Let's see, there's a question in the chat. Hi, thanks. Someone wanted to know about the NASA Night Sky Network, and that is a collaboration of more than 400 astronomy clubs across the US. I'll stick a link in the chat for anyone who's interested. If you are not part of your local astronomy club, they're also a really great resource for becoming engaged in citizen science of all sorts. I highly recommend you do that. And there are also plenty of online webinars that they offer, so you can join from just about anywhere. So glad to talk about that. Are there anything, last words that any of our presenters wanted to share? Something you thought about on your way through? Yeah, go Rob.
Honestly, just really blessed that we have so many great already participants to our project. We have yet to officially launch. We're still in beta test phase. And due to our citizen scientists who have been participating in our project, it has just gone in such a completely slightly different direction. And it's just for the better for it. So really, if you're anxious or concerned about signing up, definitely take that plunge. Do sign up for our projects, because you really have the opportunity to make this project your own and honestly make it for the better. So please, we really appreciate having all of you participating in this as well.
Absolutely agreed. I want to welcome also Mark Kushner, who leads citizen science for NASA Science Activation Group. And I want to say hello and thanks for always having our backs and participating and making a lot of great science happen.
Vivian, what a great session. Oh my goodness, you're like a perfect radio announcer voice, and so smooth and made everybody feel so happy. Thanks for doing this.
Thank you. Thanks. And Caroline, thank you so much. And Darlene and Tara, all here from SciStarter, and Jennifer Shirk from Citizen Science. I want to thank you all so much for having us. Thank you.
And thank you, Vivian. Great job hosting. We knew that you'd be an amazing moderator. I see Stella's hand up. Stella, did you want to say something?
Yes, I do. Thank you. All I want to say is, again, thank you for opportunities like this that bring us together. Thank you for those who are actually tuned in. You can tell there are lots of eager individuals here who would love to work with you. So again, please feel free to reach out to us. And again, thank you for your contributions. We talk about citizen science as it's detached from our everyday life, but something, citizen science, sometimes what pushes science forward. So it's because of you that we are here, and we're learning a lot about some of the most incredible phenomena in the universe. And don't forget to observe the sun with a filter, but the sun's a variable star and shows lots of really cool stuff. Or with a radio telescope, do it. So that's all I have to say. Again, thank you so much. Thank you all. actually.
Okay, one more quick thing. There's a lunar eclipse coming up this Wednesday morning. Don't forget to view that just as your own beautiful inspiration for doing more great science. If you're on the West Coast, it's around 4 a.m. Check timeanddate.org should have that for you. Yeah.
I'm glad somebody mentioned the sun. We have friends in India who are tuning in. The sun is probably just starting to rise over there. So not too early to get started there on in my neck of the woods, and some of our friends from the Citizen Science Association, if you want to wave, our partners in this whole series. I know they're on the East Coast and it's getting a little dark out here. So maybe we know what we're doing this evening. We can give it a shot. Thank you, everybody. Mark, thank you for making this possible too, with support from NASA. We hope everybody gets involved in these projects, of course. Caroline and Tara, thank you for somehow pulling all of this off. I know you had a great time getting to know all of the speakers and some of the citizen scientist volunteers that we've heard from. I want to remind everybody, in case you missed some of the events today, in case you weren't like some of our friends here who remarkably tuned into every single one of the events. I don't know how you did it. All the recordings are up already on scistarter.org/NASA. And that's also where you can find details about all of these projects. You'll link over to their websites, but we give you some basic information. Some of you have asked about the certificate. If you tuned into 2 events, and this is one of them, and then you get involved in one of the affiliate projects, and you'll see what that means when you're on the website, we'll send you a nice certificate in the coming weeks. So Tara, Caroline, Jennifer, Sarah, Mark, anything to add?
Huge thank you to SciStarter, to CSA, to you, Darlene, for your leadership over the years. SciStarter, by the way, is your ticket to all kinds of interesting citizen science beyond NASA. Citizen Science Association will help you meet the rest of the citizen science community. The month-long CitSci virtual meeting going on all month. There's a whole other week of that left. And Jennifer Shirk is the grandmaster of that. Sarah, you're my partner. I don't know what I would do without you. And a magician. Caroline and Tara, wow, you guys, we gave you like not enough time. Just so you all know, our grant process at NASA has been somewhat messed up. And this team had like 6 weeks to assemble this whole thing. Anyway, I can't believe you got this together and did such a great job. I've been hearing so much good vibes about this on Twitter. Everybody's been so enthusiastic about how this came together. I am so impressed and so grateful. I would do this every day if it were possible. Thank you.
Well, just in addition to what Mark has said, I'll say thank you to him and to NASA for seeing the value in making these connections between the people who lead projects and the people who are bringing their energies, their inspirations, their insights to these projects so that we can all learn together how we make the science through citizen science possible and these powerful, engaging experiences for everyone who gets involved. So thank you, NASA, for leading in those ways, and to everyone who is exemplifying excellence in citizen science as project leaders, as participants all around the globe. So exciting.
Woo! All right, Darlene, do you want to see us out?
Sure. We did a cheer yesterday, by the way. You'll see that recording on the website too. We'll see how it turned out. I'm not going to force you all to do a cheer. I just want to thank you all. At the end of this, when it closes, you'll see a little poll that comes up. Go ahead and fill it out, and then we'll send you a survey to see how we can improve upon this for next time. But everybody out there, please get going on citizen science projects, and thank you so much. Enjoy the rest of your weekend. Take care.
Great job, everybody. Thank you.
Thank you all. It was so much fun.
Thank you.